The final thing to consider in this lesson is satellites. Now, we will talk about satellites in more detail in future lessons. So the first thing that we would consider is that we assume that the orbit is circular. Now, it probably is elliptical, but we assume that this is moving in a circular path. Now, we've already looked at circular motion and centripetal force. Now, we know that centripetal force is just the name given to the resultant force towards the center, which is provided by the weight. So if we have the weight mg is providing the centripetal force mv squared over r, then we can get rid of the m, which is the mass of the object. We're not considering the mass of the planet here. And we can get an expression for g, which will be v squared over r. And we've talked about centripetal acceleration before, and that shouldn't surprise us that v squared over r is centripetal acceleration. So at a particular height above the Earth's surface, then the value of g, the acceleration due to gravity, is the same as the centripetal acceleration. So let's look at an example. So we've got a satellite, we've got a height of 500 kilometers above the ground. First of all, calculate the value of g. So we've got v squared over r. Well, but we don't know v, so we're going to have to go to our expression from the previous screen, where we know the mass of the Earth and we know the radius. Now we've got to be careful here. So that will be the radius of the orbit, but that's the radius of the Earth plus the height. So this is a really common mistake. So we've got the radius of the Earth is 6,400 times 10 to the 3 kilometers, plus the height, which is 500 kilometers, 510 to the 3. Those two added together is the radius between the center of the Earth and the satellite. And then obviously we square it as well. So we should expect a value slightly lower than 9.81. So even 500 kilometers, obviously this is a very misleading diagram here, that's still a relatively low orbit. So g is just slightly less than it would be at the surface of the Earth. So we can find 8.41. Okay, after that, well, now we've got an expression relating v, r, and g. So we've found g, so we can make v the subject. So v is equal to rg square root. So once again, the radius is the total radius. That's the radius of the Earth plus the height, all in meters, multiplied by the value of g that we found. And we get a value, in this case, of 7,616. Do bear in mind that we would expect to get a very large value of velocity. So satellites are really moving, especially in low or relatively low orbits. Expect hundreds of meters per second. So this is kilometers per second. This is many times the speed of sound. So this is what we would expect.